Hello students, you are welcome to another tutorial by Brain Boosters Tutorial. My name is Ibukunluwa. Today we'll be looking at a topic that is very important, and the topic says indices. Indices, that's the topic that we're looking at today. Before we continue, if you are new to this YouTube channel, kindly subscribe and click on the notification bell in order for you to be updated on any new video I release. Indices. Introduction. Indices shows how many times a number or letter has been multiplied by itself. For example, a squared. Indices shows how many times a number or letter has been multiplied by itself. For example, a squared. A squared means a times a. It means a has multiplied itself twice. That is, we have two a's there. A cube. A raised to power 3 means a cube, which means a times a times a. This means a has multiplied itself 3 times. Then we have a raised to power 4. A raised to power 4, which means a raised to the power of 4. A raised to the power of 4, and that's a times a times a times a. This means a has multiplied itself 4 times. Indices is the plural of index. An index can also be called exponent or power. So indices is the plural of index. If you I have a video on index, and once you have, you can just check the description box below. You'll see the link to that particular video where I gave a summary and an explanation on index. So let's continue. Index laws. Index laws. Number 1, we have multiplication law. Multiplication law. That is, when numbers with the same base are multiplied, the indices, that is the power, are added. For example, a raised to power m times a raised to power n is equal to a raised to power m plus n. The law says that when numbers with the same base, for example, that is a and a are the same base here, are multiplied, then the power or the indices will be added. So a raised to power m times a raised to power n is equal to a raised to power m plus n. So let's look at some examples. This is an example here. A raised to power 3 times a raised to power 4 is equal to a raised to power 3 plus 4. A raised to power 3 plus a raised to power 3 times a raised to power 4 is equal to a raised to power 3 plus 4, which gives us a raised to power 7. This gives us a raised to power 7. Another example, a raised to power 2 times a raised to power 3 times a raised to power 1. We can also consider the bases. The base are all the same for the three figures here, and in the alphabets we have the same base here. So it's equals to a raised to power 2 plus 3 plus 1. It's equals to a raised to power 2 plus 3 plus 1. 2 plus 3 is equal to 5 plus 1 is equal to 6. So the answer is the answer is a raised to power 6. The answer is a raised to power 6. So a raised to power 2 times a raised to power 3 times a raised to power 1 is equal to a raised to power 2 plus 3 plus 1. So which goes to a raised to power 6. We have a unique question here which says ab squared times a squared b raised to power 5. Ab squared times a cube b raised to power 5. Firstly, you group the alphabets. Put a's together and b's together, and that's a raised to power 1 times b raised to power 2. This a that we have here is raised to the power of 1. It's just that the 1 is hidden, so now we have to bring it out. A raised to power 1 b raised to power 2 times a raised to power 3 b raised to power 5. Like we said, we should group the alphabets. So to be a raised to power 1, we have 1 with as the exponent or the index of a here. Then we have 3 as the power of a here. So a raised to power 1 plus 3, then b multiplied by b raised to power 3, the power of b is 3 is 2, sorry, the power of b is 2 plus the power of b is 5, so b raised to power 2 plus 5. So when you multiply a raised to power 1 plus 3 is equal to a raised to power 4, b raised to power 2 plus 5 is equal to b raised to power 7. Another example, m raised to power 2, m raised to power 6 times m raised to power 3, n raised to power 7. Collect the like terms. You collect the like terms, and when you collect the like terms, that's m raised to power 2 plus 3, then times n raised to power 6 plus 7. The n has 6 and 7 here, so we just group the numbers like that. So m raised to power 2 plus 3, then n raised to power 6 plus 7. So the answer will be m raised to power 5 times n raised to power 13. So m raised to power 5, n raised to power 13, that is 6 plus 7 is equal to 13, then 2 plus 3 is equal to 5. We have another rule which is division rule, that is when numbers with the same base are divided, the indices are subtracted. When numbers with the same base are divided, the indices are subtracted. So a raised to power m divided by a raised to power n is equals to a raised to power m minus n. So the indices are subtracted when we have division. A raised to power m divided by a raised to power n is equals to a raised to power m minus n. Excuse me. Example 1. A raised to power 4 divided by a raised to power 3. A raised to power 4 divided by a raised to power 3 is equals to a raised to power 4 minus 3 equals to a raised to power 4 minus 3, which goes to a raised to power 1, which is also equals to a. The second question here says 4a raised to power 7 divided by 3a raised to power 3. Leave the coefficient because it's not divisible. So since 4 divided by 3 will give us decimal, we leave the coefficients, we just leave the number of the figure like that. So we have business with the a now. A raised to power 7 minus 3. A raised to power 7 minus 3, and that gives us 4 over 3 multiplied by a raised to power 4. 7 minus 3 will give us 4 here. So in this situation like this, we just leave the coefficients. Example 3. 21b raised to power 6 divided by 7b raised to power 2. In this scenario now, 21 divided by 7 is equals to 3. So b raised to power 6 minus 2. So 6 minus 2 is equals to 4. So then we have 3b raised to power 4. In this case here, 21 is divisible by 7. So that's why we have 3. So 3b raised to power 4 is the answer, because 6 minus 2 is equals to 4. Example 4. M raised to power 7 multiplied by n raised to power 3 divided by m raised to power 4 multiplied by n raised to power 2. You group the alphabets. So number 1, m has the power of 7 and 4. Then n has the power of 3 and 2. So m raised to power 7 minus 4, then n raised to power 3 minus 2. So it's equals to m raised to power 3 n multiplied by n raised to power 1. So because 7 minus 4 is equals to 3, 3 minus 2 is equals to 1. So m raised to power 3 multiplied by n raised to power 1 is equals to m raised to power 3n, because n is raised to power 1 here. So m raised to power 3n, that's the answer. We have law of brackets too. Law of brackets. So for example, open bracket x raised to power m close bracket raised to power n is equals to x raised to power m times n. So we have in the bracket we have x raised to power n, and outside the bracket we have n. So what we are going to do is that when we open the bracket, we just multiply the power. The power, we're going to multiply the indices. So it's equal to x raised to power m times n. So let's look at an example. 2 raised to power 3 open bracket 2 raised to power 3 close bracket raised to power 2. So 2 raised to power 3 squared now is equals to 2 raised to power 3 times 2. We're going to multiply the indices. 3 times 2, 2 raised to power 3 times 2, which is equals to 2 raised to power 6. So 2 raised to power 3 squared now is equals to 2 raised to power 3 times 2, which is equals to 2 raised to power 6. We also have law of negative power. Law of negative power. For example, x raised to power minus m is equals to 1 over x raised to power m. Law of negative power. When you have negative power, how will you solve it in indices? So it means the law is that since we have minus m there, it should just be 1 all over x raised to power m. 1 all over x raised to power n. So for example now, a squared divided by a raised to power 6 is equals to a raised to power 2 minus 6, and is equals to a raised to power minus 4. So we are going to apply the law of negative power here now. A raised to the power of minus 4 is equals to 1 all over a raised to power 4. So once you make a raised to power 4 the denominator, the negative sign on minus 4 will disappear. So let's look at it again. A squared all over a raised to power 6 is equals to a raised to power 2 minus 6, which is equals to a raised to power minus 4. 2 minus 6 is minus 4. So and that gives us 1 raised to power a raised to power 4. 1 divided by a raised to power 4. We also have the power of 0. The power of 0. This law states that anything raised to power of 0 is 1, and this is a general law. It's a kind of common law in mathematics. So 3 raised to power 0 is equals to 1. 400 raised to power 0 is equals to 1. 1 million raised to power 0 is equals to 1. So that's the law. So today we've looked at indices, and we are meant to understand that indices is the plural of index, and index means power or exponent. That this also means when numbers are multiplying themselves. So we've looked at the laws that we have there. Number one, we said once we have multiplication, a raised to power m times a raised to power n now, we just, and they have similar base. A is the base here. You just say a is equals to m plus n. So it gives addition. That is, when numbers with the same base are multiplied, the index or the indices are added. The indices are added. So a is for m plus n. So we also looked at division rule, which says when numbers with the same base are divided, indices are subtracted compared to the multiplication rules where they are added. If for the division they are subtracted. So for example, a raised to power m divided by a raised to power n is equals to a raised to power m minus n. We also have law of brackets. So for example now, x open bracket x raised to power m close bracket n is equals to x raised to power m times n. X raised to power m times n. The law of negative power says that x raised to power m is equals to 1 over x raised to power m. So the law of negative power is more like a fraction. It will convert the equation to a fraction. So the base raised to power, if the base has a negative index now, the answer will be a fraction. To be 1 over the base raised by the power, 1 over the base raised by the power. So for example, now x here is the base, y m is the power now, or the index. So x raised power minus m is equal to 1 over x raised power the power of 0. This law states that anything raised to the power of 0 is 1. Anything raised to the power of 0 is 1. So 3 raised to the power 0 is equal to 1. 400 raised to the power 0 is equal to 1. So that's what we have for today. This tutorial is brought to you by Brain Boosters Tutorials. If you haven't subscribed to our YouTube channel, kindly do so. And this is our website, bit.ly/omojime-edu-consult, bit.ly/omojime-edu-consult. So I'll see you in our subsequent lessons. You can just practice and revise the questions, get your textbooks and practice more. And I wish you success as you practice. So thank you very much and bye for now.